Hi everyone and welcome to this channel. Today, or this lesson is going to be about division by radicals, specifically the radicals in this simple form a divided by square root of b. So numbers like 3 over square root of 3 or 5 over square root of 5, take away square root of 3, etc. involve dividing by radicals. So what are the radicals? A radical is a number that is written using the radical sign, which is this one here, and we call it square root. So for example, the numbers that look like this: square root of 3, square root of 7, square root of a, etc. Sometimes we like to rewrite them without the radicals in the denominator. So what we're going to do today is to go through how do we actually do that. But before we do that, I would like just to show you where the numerator and where the denominator is. Not that you don't know, but just to recall it. So, for example, a divided by square root of b. So the numbers or letters above the line, they are in the numerator, and below the line, like square root of b, they are in denominator. So how do we do removing the radicals from the denominator? So we're going to multiply this fraction by square root of b over square root of b. So please note that we are actually multiplying by whatever fraction, whatever radical we have in denominator. So like square root of b over square root of b, and this is possible because this is equal to 1. Okay, square root of b divided by square root of b is equal to 1, which means that the fraction that we have, it doesn't change, because when we multiply by 1, nothing is gonna change. So let's have a look at some examples. So I already have a few examples here. So the first one is 3 over square root of 2. I'm just looking for color. I'm going to use yellow. So what I said before, it's 3 over square root of 2. In order to get rid of the radical in the denominator, we're going to multiply by exactly the same radical. So it's square root of 2, but because this is, an equation, whatever we do on one side or another side has to be equal. And if I just multiply denominator, then my expressions on the left-hand side and the right-hand side are not the same. So what we're going to do here is just add square root of 2. Now, we already mentioned that this is equal to 1, okay, equal to 1. So therefore, this fraction doesn't change at all. And then we're going to go with equal, and I'm going to go through steps. We're not going to do cancelling or simplifying in our heads. So if you remember, how do we multiply? So we multiply across. We just multiply across. So 3, in this case, 3 times square root of 2, and in denominator, square root of 2 times square root of 2. So now this is going to be equal to 3 square root of 2 over. Now we do have 2 lots of square root of 2. Right? So, and if you do remember the index law, so instead of, repeating itself, we can have simplified version of this. For example, a times a is the same as a to the power of 2. So we can do the same here, square root of 2 over 2. But now we can simplify, cancel out 2 and 2. I went through this in class, how and why we can do this. So if you would like to know, come to my class. So the final answer would be 3 times square root of 2 over 2. Okay? So now you can see we don't have radical in denominator. Now let's have a look at the second example. So what color? Let's go with green. So we still repeat this, okay? And please do so. Times, we're going to multiply by 1, that does look like square root of 3 over square root of 3 equal to 9 times square root of 3 over. And now, if you want, without doing too many steps, we can see that now square root of 3 is multiplied by itself. So there's like 2 lots of it. So we can do it like this. And then we cross out, cancel out. We're going to end up with 9 times square root of 3 over 3. But now we can simplify further. So what we can do, 9 divided by 3 is 3. So our final answer is 3 times square root of 3. So next one, we have 11 over square root of 7. So what you can do now, you can actually stop the video and you can try to do it by yourself, and then you can check, the answer. So I'm just going to write now without explaining, and then you can have a look if, it does make sense. So if not, then again, come to my class, and I'm not even joking. Everyone is welcome. Crossing out. Let's have a look what we're going to end up with. And this would be the final answer. Hopefully I'm not making mistakes, but let me know if I did. Okay, so the next one, it does look a little bit different. So we have now 4 over 3 times square root of 2. Please note, we just have, this can be written like this. It could be written like 4/3 times 1 over square root of 2. So we just need to get rid of square root of 2, okay? So, or rewrite, not really getting rid of, it's just like, yeah. So therefore, we don't have to multiply. I'm just going to go back to what I had before. So we don't have to multiply by 3 times square root of 2, even though you can, but that would involve maybe one more step. So I'm just going to do this, okay? So without 3 equal to, so don't get confused with something else that I'm going to do in the next video, which is about conjugate pair. So, but if you have here 3 times, just like this, just 3 times square root of 2, all you have to do, look what the radical in denominator is, just in this case square root of 2, and you multiply numerator and denominator by it. So this is going to be equal, oh, those colors are beautiful. Okay, so I'm going to have one more step here because it's a little bit different from what you have seen before. Now, 2 lots of square root of 2, we know that's going to go like this, okay? So, but before this, what I could have done, which I'm going to do now, so if I cancel out square root of 2 and square root of 2, you're going to see that, sometimes you just get confused, like, oh, cancel out, but then we're going to end up at the same thing. So we're not going to do that because we want to simplify version and not to have radicals in denominator. So here, the final answer, I think, is going to be this. Yeah, it looks like it, 3 times 2. Remember, when you don't have any sign between the number and the brackets, it means multiplication times. 3 times 2 is 6. We can simplify this a little bit further. 4 and 6, we do know the highest common number that can go into 4 and 6 is 2. So we divide both by 2. Let's look another number, yellow. So cross by 2, we're going to be left with 2. Cross by 2, we're going to be left with 3. And this is the final answer. Okay, let's do one more example. Again, tiny bit different. Now we have radical in numerator as well. So here, okay, in numerator and denominator. Again, we're not going to worry much about number 2 because it's 2 times square root of 2. It's not 2 take away. That's a different process. So you're going to see that in another video. So I like yellow. So what I'm gonna do, but not that one. Let's go back. Okay, so I'm just gonna go like this. I just rewrote what we had. Times square root of 2, square root of 2. Now, again, I'm gonna have maybe more steps than needed, which is fine. 2 times square root of 2 times square root of 2 equal to, if you do remember how we can simplify, the radicals, square root, of course you remember. So when we have multiplication here, instead of having them split apart, square root of 3 times square root of 2, so they can be under the same root, like this. So now denominator 2, and we all remember this part here, lots of 2 lots of square root of 2, just like this. Let's do some crossing out. 2 and square root equal to, so 3 times 2, it's 6, square root of 6 over 2 times 2 is 4, and that would be the final answer. Hopefully this makes sense. So, and if you do want to see about conjugate pairs, I think I'm gonna try to record it today. Have a beautiful day and see you in the next video. Bye.